Hello, hi everyone. Welcome to today's session on problem solving through programming in C. This is a revision class where I'll be covering most of the topics that we have covered for this semester. So this is the last session for this series. So yeah, so let's wait for a few more minutes so others can join and then we'll start the session. Right? Hi everyone, am I audible? Please confirm. Anyone please type in the chat box to confirm that I'm audible. And also my screen is visible. Anyone? So no one is responding. So yeah, I am seeing someone typing something on the screen. Great. So, welcome to the last session. So, this is a reverse revision session where I'll be covering all the topics covered till date. And yeah, if you have any queries, the instructions are same. Type in the chat box. At any instant you face that I'm not audible or my screen is not visible, you inform me by typing in the chat box, right? So let's start this session. And then at the end of this session, I'll be taking questions from you guys, right? So in the last session, what we did in yesterday's session, we were finishing up with the some last topics that needed to be covered, right? And we were solving problems on file handling. Mm, right. Oh yeah, we had covered topics, structs, pointers, and file input output. Now today I have to finish up dynamic I have to finish up the remaining part of file input output, and then lastly I will show you dynamic memory allocation. What is meant by dynamic memory, right? So in the last session we already saw two important functions that are really useful in doing file input out from C. So one was fputs. What it does is it takes a raw string and simply writes it onto a text file or any output stream that you specify, and it does not parse the string before passing it to the output stream. So it simply takes up the raw C string and passes to the output stream. Then let's say if you want to put some formatted string onto the output stream, then you can use fprintf function. So it can use formatted. It's basically passes the strings, converts, reads the entire string, converts it into raw string, and then that raw string is passed to the output stream, right? The last function that we are going to see today is the fwrite function. So why it is useful? Let's see. So fwrite, it is used to write arrays to files, right? If you want to write a array to a disk, you can use fwrite. The syntax is as follows. The function prototype looks like this. So it returns an integer. So it returns a integer, and let me just write in the right. Yeah. So this is the actual syntax. So size t is basically unsigned integer. Yeah. So size t is an unsigned integer. So in the function prototype, is it visible to everyone? So is the text visible? So let's see what I'm saying here. So basically, this is the function prototype for the fwrite function, right? So the function returns an output value belonging to the class size t, belonging to the type size t. So what is size t? Size t can hold integer unsigned integer values. Okay, so size t is used to hold unsigned integer values, right? Then you have function name fwrite here, and then you have the function argument. So first one is constant void pointer. So it's a pointer to the beginning of the array, right? So this is so let's say I have this array, right? So let me take an array. So yeah, let me erase the problems that I we already saw yesterday. So yeah, is revision class. So I'm Rupesh Kumar. Today is Saturday, April 12, 2025, 3 to 5 5 right? Yeah. So yeah, then yeah, what you were saying? You were saying that we have an array. So let's say we have this array. So let's say we have this array. So we all know how arrays are stored in the main memory, right? Every one of you is familiar with that concept by now, hopefully. So let's say you have this main memory. In the main memory, there is contiguous chunks of data, right? It can hold continuous chunks of data, right? This is our main memory, right? So how is this array stored in this array? We all know this. How are arrays stored in the domain memory? So this array contains 1, 2, 3, 4, 5, 6, total 6 elements, right? So it will so it will take a chunk of this main memory that can hold and let's say this array belongs to the integer type, right? So it's an integer array, right? So how much memory it will occupy? It will occupy the space for total six integer values, right? So this is the total space for six integer values, and this is the starting address memory location, right? So this is the started memory location for this array. So let's say so what this memory location corresponds to, this location corresponds to the value stored at the zeroth index, which is this element, right? So it corresponds to this zeroth index element. So this memory location corresponds to this zeroth index element, right? Now, how what does fwrite takes here as input? So the input to fwrite function is the address memory location of this zeroth index element. So basically this is exactly the input that you pass as the constant void pointer here. Then what is size t? Size. So basically again you are saying a variable of type size t. So basically it can store an unsigned integer. And what is the size? So it says size. What is the size of each element of this array? So what does this mean? So this size variable essentially takes an input. The input is size of int, right? So how much space does one integer value takes as input? So that value has to be passed to this size variable, size argument, right? The third one is size t again. So again, unsigned integer, and it says nmemb. So basically, you can pass any variable. So what is this? Number of elements in the array, right? Number of elements in the array. And lastly, you have this output file stream. So what is this? Stream where the output has to be put, right? Stream to which output has to be sent to be sent, right? So this is what this is how this fwrite function works. So let me show you a working example. Hmm. See, uh, So we include the standard IO library for doing this operations, stdio.h, right? Then we declare use the main class. And what I'm saying, we are going to use f. So the function that we are going to use today is f write an array to a file using C program, right? So this is the problem that we are going to solve today. So I hope my text is visible, whatever I'm writing here. So let's create an array containing integer values, right? So let's declare a size for the array, anti-size. So I can length of the array, length. Let's say it contains five elements, right? And then I can create the size of the I c- and then I can create an integer array. Let's call it ARR. Then pass in five elements to this 1, 2, 3, 4, 5. Right? So this is an integer array containing five values. Now what I want to do, we want to write the output for text file, right? So open the let's open the output stream. We already saw yesterday what we were doing, how to do this. So you can declare an file object file f is equals to open, f open, right? So f open, you pass in the file name followed by the mode. So let's say file name is i file io3.txt and you open it in the write mode, right? So you pass in w here. Now what you do, you put the array onto the output stream. How to do this? We can use fwrite function. So fwrite and the number of characters anti result. So I can store the number of characters returns in a integer variable result. And now what I have to do, I have to give the pointer to the starting address of the array, right? Starting element of the address array, so which is index 0. So what is that? That is ARR, right? We all know this. Then I have to pass in the size of each element that this array holds. So I can use the size of function and I can pass size of ARR at 0. So what is the size of the element stored at the zeroth index of ARR? So I can use size of function here. And then how many elements I'm storing? I'm storing five elements. So I'm passing length here. And then finally I have to pipe in the output file output stream. Now the character will be stored. Then I can close the file, right? Then finally I can give the user a prompt that what we have done. We have written an array containing an integer array containing this much elements, right? File. So how many elements we put? We to total n element, ln elements, right? And then finally, what we can say, we can tell the user the total number of characters, and we can also tell how many correct total number of characters have been written. So I can just pass percentage here and pass result here, right? And then finally, we can exit our program. Everyone, is the program clear? So I hope this is clear. So initially we created an array, integer array containing five elements, and this is perfectly fine declaration of our arrays in C, right? You can declare integer arrays like this, and I have entered five elements. Fine. Then the length of the array is five all itself. Then we want to write the output to a text file. So we need some output stream, right? Where we want to put the output. So we create that stream by opening the file io3.txt using the fopen function, and we open it in the write mode. Then finally, what we are doing, we are putting the array onto the output stream. So we can use fwrite function here. It takes in the starting address, the pointer to the starting variable, so index 0 variable. Then the size of each element that has to be written onto the output stream, and then total number of elements present in that array, right? And finally, the output stream f here, right? So we have written everything onto the file, then we close the file and give the user some out instructions, so like what we have done. So everyone, is this clear? Is the program clear? Please confirm by typing in the chat box. Do you have any doubts in how to use this functions, right? It at any step in the program, do you have any doubts? Okay, fine. So I guess no one has any doubt. So yeah, let's run the program. So we can use GCC for we can use choose the compiler. So I'm using GCC here to compile my program. Then I can pass in the file name to this. So file io3.c, right? Okay. So yeah, sorry, there was a mistake in my program. So it has to be file pointer whenever I'm creating this file stream. So it's a pointer variable. It's not a static variable, right? Hmm. Yeah, so we have successfully compiled our program. So there was a mistake in my program that I have corrected, right? So I had not declared it as a file pointer, and fopen function returns a file pointer. It does not return a file instance of the file type. It returns a file pointer. So I missed this asterisk mark here. So I missed this pointer here. That's why my compiler was giving me issues. Now you can see the program has run perfectly fine. So now I can run the output, and then you can see so I can always run the output by dot front slash a dot out. So yeah, since it's a revision class, I should also explain these steps again, because this comes under revision. So you all remember this GCC compiler, right? So whenever you want to compile a file, C program, you can type in GCC on the Unix terminal or Ubuntu terminal, Linux terminal, and then followed by the file name. So my file name is file io3.c, right? Then it will compile your program. So you can also give a nice file name to it. So file name, for example, file io3. So you can also file IO. You can also give a nice file name here using -o flag here. But if you don't give any flag here, then it will create a default file with the name a.out, right? You all remember this? So if you don't give any output file name, then it will create a file a.out. Otherwise, you can also give a file name like -o, and file name is file IO, right? So now you can see I have a file created with the name file IO. So you can also see I have a compiled binary has been created here named file IO, right? So now how to run this compiled binary on a Unix and Linux terminal? You can type dot front slash file IO, right? And then it will run the compile binary, and then you can see the outputs thrown out by our program. It says we have written an integer array containing 5 elements to a file. The total number of character returns were 5, right? Now how to check if this has been written? Let's open up the file that we were trying to write to. So it was file io3.txt, if you remember from the program. And yeah, there is some issue in the IO. Okay, just let me see what is there. I'm missing something here. Hmm. The syntax looks correct. So let me see. My program has some issues because we are seeing this strange output. So the file name is correct. File io3.txt. Integer array is correct, containing 5 elements. Mm, yeah, everything else is fine. Okay, so it's writing random characters in our output file. So there is some mistake in the function. Hmm. So let me look into this. Yeah. Hmm. Okay. Okay. Yeah, yeah, yeah. So yeah, in this case, we have to make one change here. Now let's compile our program. Mhm. Okay, so some translation is happening. Hmm. Okay. Hmm. Share the screen first. Yeah. Hmm. So it seems like I'm making some mistake in using the fwrite function, but documentation says this is the syntax. So do you guys know what I'm missing here? Anyone, can you help me? Anyone? Have you seen the video lectures? Okay. Yeah, was this not taught? Oh, okay, 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 okay. Hmm. So yeah, so guys, there is no mistake in our program. The issue is we are writing binary data, right? So we cannot directly read this binary data. So it's not in human readable format. So we have to write a function to read this data, right? So let's create an read ARR. So where I'll be uh, reading this data written on that file, right? Now I can open up my binary file again. So I can again open up at this using afraid. So I have to open up this in the So I will open this binary file, file.bin in the read binary mode. So RB mode is here, and then I can use fread function to read the contents into my array, right? So I can use fread and then pass in the new array where I am reading the values. So starting address for that. The syntax is same for this also. So I am reading integer variables. So in integer array, total number of arrays is length, and then the pointer is f, right? So now I have this array. Now I can print the contents from this array, right? And then I can close my file pointer here, and then I can print the binary data, binary that we read, right? So we can now print the contents of the array that we just read that we just input read from the file. So for this, I have to, for printing the contents, I have to use arrays here, a for loop here to print the contents, right? And then I can simply print the content percentage d space. I will just put a space here, and then I can print the array of content read arr at I, right? And finally exit. So this is the final program that I'll be using. The issue that we were facing was the issue that we were facing was that the program, the output that we wrote into the file was a binary file, and we cannot directly read it from here. So for that, we have to use a binary file reader. So I have used the fread function. So first I opened up the written file, file.bin, in which I have the binary data in the read binary mode. And then I use the fread function to read the input to the array read arr, and then the size of the input to be read for each element is integer, and then the length of the array, and then pass in the file pointer. And finally I print each element present in the array, right? So let's see how it works. File 3.c. Oh, so we have to use nvm function, right? Hmm. So it is print f here. Yeah. And also I have missed the terminator here, so it's not Python. Yeah, so the total, the binary data that we read was 1, 2, 3, 4, 5. Right, everyone? Can you see this output? Mm, it's always good to put some line changes every time, right? Let's run the program. Now you can see the binary data that we read was 1, 2, 3, 4, 5. So we already saw we were writing the binary data onto a text file. The array contained the elements 1, 2, 3, 4, 5, and then we wrote that data. Right, everyone? Is this clear? Anyone do you have any doubts? Anyone? Please type in the chat box. Is this clear, everyone? So there was one major thing that we needed to do here. So basically, I also explained you guys how to read files from any output file. So you first open up the file into in read mode. So I use read binary mode here, and then I can use fread function to read the file, right? So now, if anyone are you facing any difficulty in understanding this? Please type in the chat box. The one is typing. So is this clear, everyone? Should we proceed further? So let's move on to the next topic, right? Hmm. So, right. So this was all about file input and output. And lastly, I just want to tell you guys there is a type def function that you can use always to give a name to any data type, right? So I hope you have seen this in your class video lectures. So type def function is useful when you want to create, so you want to give a name to specific data type, right? So let's say no one is typing anything, so I'm not sure responding on the chat box. So I'm not sure if I'm audible or my screen is visible. But yeah, let's go ahead, right? So so how to use type def? So for example, you wanted to use so what it when it is useful when we want to use an alias for a given data type, right? What is alias? For example, you have a struct some data type, struct data, right? And it contains some values like int x and then character y. And now in your main program, so let's say you have this your main program. Inside your main program, whenever you want to create this structure, what you do? Anyone, do you know this? What you do? So you write it like this: struct data, right? S1, something like this. So whenever you want to create this data, a variable of this data type, what you do? Write the entire prototype, right? Struct data and then followed by the variable name. So we can make this easier. How we can do? We can use an alias for this, and for doing that, we need the function type def, right? So I can say the type def struct data to be SD, something like this, right? And then you can use SD everywhere, right? So you can always use this. So I can always say type def struct and followed by data, right? So I am defining this data type with the name data. So I can always create it as struct data s1, right? So I don't need to write struct every time here to create this variable s1 of belonging to the struct data type. Right, everyone? Is this clear? These are some basics that I wanted to cover. Is this clear, everyone? Do you have any doubts? Am I audible? Anyone? Am I audible? Okay, fine. So, so let's say, right, you want to create an integer variable, right? How do you do this? You say int x equals to 1, right? Everyone, you use this. So what this means, we have created a variable named variable x that we- that stores data of type integer, right? Now, what if we don't want to use the name int to we want to use some general name, some English word, just some token to define the int data type. How can we do this? We can use type def here, right? Say let's say I want to say int as numbers, right? Now let's say if I'm saying type def int numbers, those syntax is like this. So first you write type def here, then the data type that you want to make alias to, and then followed by the alias that has to be used in place of int, right? So now whenever in your program you write numbers, so let's call it number, right? Whenever you call number x, this is equivalent of saying INTX, right, everyone? So this is the use case of type def, and the most basic important use case is in declaring structs as data types. For example, you have this struct, right? So you have this struct structure that can store two values x and y, and in the program you don't want to write something like struct, right? If you want to create a variable, you will say struct data and then variable name, something variable name, right? So what is a better way? You want only one word. Let's say you want only one word to declare this data type. So what you can say, you can use type def like this. So you can see here what I have done. I used type def, then your data type, right? So this is struct containing two values, integer and character xy, and then give the name, give the alias data. Now everywhere I can say data where I don't need to use the syntax as above. I can always use this, right? This is very short, very clear that I am creating a struct of type data, whereas this is very long to write if you're creating multiple variables, right, of the same data type. Is this clear, Prajwal? Prajwal, is this clear? Am I audible? So there was a basic example with the integer data type and then structs, right? The last thing that I want to discuss is right about dynamic memory allocations. So have you seen the video lectures about dynamic memory allocations? So you should go back to those lectures, right? So this example requires us to understand the malloc, calloc, and realloc functions. So these are basically dynamic memory. These operators are useful. These functions are useful whenever you are dealing with dynamic memory allocations, right? right? These are useful. So why do you need, what is dynamic memory allocation and why do you need this? So basically, there are some times, so you all remember that when you want to store multiple values in a single variable, you can use arrays, right? For example, int array containing 10 elements. Everyone, do you remember this, right? So the issue with these static arrays is this: you need to specify the array size during the compile time, right? You need to specify the array size. This value 10, it has to be specified during the compile time. Either I can use this, or I can say int n equals to 10 and then int arr of size n, or I can say int arr containing 10 elements and I have to put in 10 elements here, right? So these are three ways you can create this integer array, right? So this is static array. You can't create add new elements to this array beyond the size 10, and you can't. You have to be sure that array of size 10 has to be created. But what if there is some problem where you want the user to define the length of the array during runtime, and then what would you do, right? So there's a difference in compile time information of the all the variables during compile and then during the runtime. So during compile time, the programmer knows whatever you want to give the size to variables, but during runtime, the user can may define what is the size I want to use, right? In those cases, you use dynamic memory allocation comes into picture in such scenarios, right? So major function is malloc. Malloc, what it does, creates a memory block and returns the pointer to the first memory location in the location of the starting, basically starting memory location of the created block, right? So now we'll be seeing a program where I will be using malloc to do this, right? So let's see how to do this. Mhm. Again, I am going to write my program and let's see if it works. So let's create a file mem.c. Right now, let's say I wanted to create an array of containing 10 elements, right? So I can create it like this. But let's say array with fixed number of elements. But now we will with arrays whose size will be determined during the runtime, right? So now we'll work with the arrays whose size will be defined during the runtime, right? So how we can do this? We can do this using malloc function. So we will use malloc function. Now the problem is, now let's say for the sake of this program, what is the problem that the programmer has? We have to write a program that takes in the input, takes in uh, an integer, a positive integer, most maybe, yeah, a positive integer and a positive integer, then uh, the program should create an array containing the table of that integer. So we all know the basic table, right? Multiplication table. Create the multiplication table of that integer. The question of the integer, right? The problem is uh the but the total number of elements in the table has to be given as input from the user, right? What this means? This means, let's say I have the, let's say example, let's say I have input, let's say we have input number is 5 and the user wants its table up to 20, right? So the array should contain 20 elements, right? And the value should be 5, 10, 15, 20. Let's say 4. Table up to 4. Yeah, I don't want to make it longer, right? Now for another run, the user inputs 6 and wants the table till 10, right? Then the array should be of size 10 and it should contain the elements 6, 12, 18, 24, 30, 36, 42, 48, and right? Now, did you see for these two subsequent runs what happened? So in the first run, the array was of size 4. In the second run, the array was of size 10. And it will be very bad programming language if you are not allowed to write a single program that does this, right? So if the C programming language only allowed static arrays, you won't be able to do this, right? You won't be able to give this functionality to the user. Why? Because you had to know the size of array in beginning before for creating this array ARR, right? But luckily, and what happens in C language, you are able to create arrays with uh, well, with their sizes defined at the runtime. And how to do that? We will use malloc to do this, to achieve this, right? So let's see how we will do this. So we all know that arrays are basically pointers. So whenever you talk about array variable, what it is a pointer to the first index element, like element at index 0. So I can always create a pointer integer array, right? Now I have created a pointer variable, right? Then I can take the input number and the number of tables entries that you want in the program, right? Then you can ask the user to enter the number of elements, enter the number, and the user will enter the number here. So you can use scanf function. So it's a revision class. So I will also explain the scanf again. So what is scanf function? Scanf function helps you to take in input from the user. So scanf %d, and then you have to pass. So this is the format specifier %d. This means I am going to take an integer of data type integer, and then you have to pass in the address of the variable in which you are going to store the input. The address is address of IP. For getting the address, I'm using the ampersand operator, right? Everyone remember this? Ampersand operator returns the memory location where the variable has been stored. Now you have the input number. Now what I want, enter the table size. So how many entries do you want in the array, in the table? So again, you will use the scanf function with %d format specifier, and this time I'm taking the input into the variable n. Now what I can do, I can tell the user. So I can tell the user um, printf that I am generating a table of %d5 up to %d times, right? So let's generate the table. Yeah. So table of IP up to n times, right? Now what I can do, so now in this program, I also want to give a brief recap on functions also. So I will be writing a function to achieve this, right? So I won't be writing the program in the main function itself. So I am writing a function. So let's call that function here. So I will simply call that function here. Right? So I can simply call that function. So let's call the function name as generate table, right? Give the input to be ARR, the array pointer, then IP, the integer input, and the number of times you want to generate the table. And then finally, you can give the user the generated table and print the generated table, right? So for int I equals to 0, I less than n, I plus plus. So since this is array variable, you have to print the elements at each index. So you can simply use printf and then percentage d times percentage d equals to percentage d, right? And then change the line. And so what is the input? Input times I plus 1, comma, the output, which is ARR at I, right? Yeah, this should work. So now you all saw that I have given the output, but one thing is missing in my program, that is this generate table function, what it does. So through this program, you will also get a brief recap of declaring functions. So functions in C. So how to use this? So first you type function return type, right? Return type followed by function name, and then this braces, and inside the brackets you pass in the arguments, right? And then you have this function block in the curly braces, right? Function block, here you do all the operations in the function and then return the value of return type. And then you can always use void if you don't want to return any value, right? So I am using a void function here. So void generate table, right? So yeah, the function is generate table. Again, I am the first into this int star ARR. So I am passing the address of the starting element of this array ARR. So what I'm doing here, I'm passing by reference. I'm not using pass by value to this ARR variable. I'm passing the reference to the ARR variable. Right, everyone? Do you remember this? Whenever we use pointers to pass values to variables to arrays to functions, we are passing their references, not their actual values, right? Then I will take the input and then I will take the n variable. So last two, this input and n variables are passed by values, and the ARR variable has passed as a reference to the array. Now what I need to do, create a memory block and assign its first location to ARR, right? So I can use this ARR equals to int pointer. I will explain the syntax of malloc, right? Size of int into n, right? And then finally, so now we have created the array. Now we have to fill in the array, right? I equals to 0, I is less than n, I plus plus, and the value at ith index has to be error at I equals to I plus 1 multiplied by IP, right? Now this program finishes and you will get the answer. And after you have done this, after you have printed the values, you can free the memory. So you can free the ARR pointer here. So there is a free function that clears any memory that has been created, right? So this program helps you to understand dynamic memory allocation as well as functions in C, right? And also I've explained an idea on how to do uh, pass by reference argument passing. Right, everyone? Is this clear? So let's look at the malloc syntax first here, what it's doing. So the syntax of malloc looks like this. So how this malloc function looks like? So the function prototype is like this. So it returns a void pointer. So basically you have to typecast, right? And then function malloc and then size. This is the prototype of function malloc, how it works. So malloc always returns. So malloc returns generic pointer of type void asterisk, right? So it returns a generic pointer of type void asterisk, void pointer, and this is by default defined in C programming language, and you can typecast this void pointer to any data type of your choice, right? So any pointer data type, and in this program you can see I have typecast to it to integer pointer, right? Int asterisk. Can you see this, everyone? So this should be clear from here. So I'm typecasting it to integer pointer data type. And then I have to pass the size of the memory location that I want to create. So I have created the size of int up to n, right? Size of int into n. So total n integer values, each occupying size of int. So size of int basically gives you the size of integer data type, right? So this is how malloc function works. So now arr points to the beginning address of this memory chunk. Now I can access each index and fill in the values. Finally, I am printing the arr values here, and then I am freeing the arr variable. Now, one thing you may notice here is I am passing arr to the function. It is being modified in the function itself, and then I'm using that output in our main function. How it is possible? Because we are using pass by reference. We are not using pass by value here. We are passing the reference to the arr variable, right? Let's see if our program works. Okay, so yeah, one more thing. This malloc function is not declared in the as standard library. It is defined in the static stdlib dot. So I have to include this header file also. So stdlib.h, right? So so let's say I want a table of 5 and the total 10 entries. Okay. So there is some bug in our program. Yeah. So it seems that this dynamic memory allocation is not working somehow. Okay, so what I can do is I can simply push move this print part into this generate function itself. Yeah, now it's working. So let's see what mistake did we do. Okay, so in the earlier step, I was saying ARR variable has been passed by reference, right? So its memory location should have been visible in the main function. But the problem is what was happening is that this malloc has the scope of this function itself. This malloc function call has the scope of this function itself. So what happened when this program this function exits, that memory becomes a garbage memory because that is not accessible by the main function. So that's why we were seeing garbage values. So to eradicate this issue, I simply moved the access to the ARR variable inside the generate table function itself, right? So now I can run the program and I can see. So now I can input 4. I want a table up to 20. So we will generate a table up to 20. Everyone, can you see this? In the same program, I was able to store 20 elements as well as 10 elements, right, everyone? Do you have any doubts? Do you have any doubts in this program? 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 Great. So let's move on to the next thing. So this was all memory management in C, right? So you can also look into other functions if you want. I will cover them in the end if there is time, right? So other functions are calloc and realloc. The difference is malloc does not assign any values to the created memory location. Calloc fills those memory locations with value 0, right? The only difference is this. Calloc essentially creates the memory location and slashes it with the value 0. And the realloc is used when you want to change the memory, expand or expand the previously allocated memory, right? Then realloc is used. So this is how this works. So so the next problem is repeat the above experiment with the calloc operator and then use the realloc operator to expand the memory size if you want during the program, one single run, right? So these all things have been taught in the video lectures itself, right? So do you want to explain this realloc and calloc, or you will be able to get it right from here? Anyone, please confirm if we should move forward or you want me to explain these again. Okay, fine. So let's move on to the next function. So Prajwal, you were saying no. Was it for a doubt or what? I'm not sure. Please just you want me to explain it again or we can move forward. Prajwal, please confirm once. So I'm great. So this was all about everything that has been covered during this semester for this course. Now, and when I was explaining these 2 to 3 problems, I already covered some parts like functions, right? I have already done this, and I have already done one-dimensional arrays. So there are a few more topics that I want to cover during this revision class. So let's go through them one by one, right? So is it fine with you if I explain this in the text itself and I do not write the program for it, or you want me to write the programs? So that will be up to you. So let's move topic by topic and let's see what you want, right? So during the initial weeks, the session started with the flow charts. So I hope you have no doubts in flow charts. Anyone, do you have any doubts in flow charts? So flow charts are basically pictorial representation of algorithms. So by now you yourself are able to write some basic algorithms. So you should be able to understand this all on your own. So I'm not going to cover flow charts here. I hope you don't need it, right? Great. So then you all saw the assign basics, simple operators in C. So the operators were arithmetic operators, Boolean operators, then assignment operator, then comma operator, then operator precedence. You all saw that. So I have some problem on the operator precedence here. Before that, I want to explain little bit more about on macros. I want to go to the topics of macros. So macros, what are macros? You all should remember this. Macros are used. Macros are basically preprocessor directives. What the compiler does, the compiler takes the macros. The basically what compiler does, compiler finds, searches the program, is the program for macros, and it replaces the macros with the contents of the macros. A basic example is, for example, you have defined hashtag define x with 2. So what, and in your main function, what you are saying 0, you are saying int y, and you're saying in the main function if x, right? If x, print x is declared with non-zero value, right? So this is what the program will do in the main function, or even in the global scope. You haven't declared any variable x, and you are using if x here. So what the preprocessor does, it searches for x in x token x for in the entire program, and whenever it finds the string x, it replaces it with the value 2, right? So it will be replaced with true, and you will find it, right? So this is a very simple, very basic explanation of macros. But let's get to some real problems where these macros will be useful. So basically, macros are useful where you have to use some basic structures in the C program again and again and again and again. For example, whenever you want to write a for loop, you have to run it again, write for again and again, right? So let me show you an example where it will be useful here. So I will write a macro for running for loop, right? So let me create a file macro.c and then hashtag include, right? And int main. Let's say I have int array, an array containing these elements 3, 4, 5, right? So now I want to print the array contents, array contents. So just look at the build up, how I'm explaining, how I'll be using this. Then what I can do, let's say I want to multiply each element of the array by 2, right? So how can I do this? I have to run a for loop, right? For int I equals to 0, I is less than total array elements 5, I plus plus, right? And then I can say arr at I equals to arr at I multiplied by 2, right? Then what I can do, I can print the array. So again, printf array, the mod the array with elements scaled by 2, right? And then again, what you would do, you will again write this for the for int I equals to 0, I is less than 5, I plus plus, and then print the entire contents, right? Percentage d, comma, arr at I, right? You can write this program every time you want to do this. Printf backslash n for good clarity on the terminal. Now again, I want to multiply, I want to add 2 to each element. The array. So what I will do, I will again, so I'm just copying and pasting the contents, right? I want to add 2 to each element, so I will use plus 2. And then again, I want to print the modified array, right? Now, can you observe one thing? What is one thing that we are doing again and again? We are using this for loop again, and we are running it till 5 times, right, everyone? So let me show you a way that will help us to remove shorten these calls every time we are doing this. The easiest way is writing functions to do this, but will have to write functions to add one function to add multiply each element by 2 and one function to add 2 to each element, right? So what if I say I can what if we want to just so the only redundant part in this entire line is this for loop, right? First for scaling the values, then printing the values, then again adding the values with value 2, then again printing the value, right? So we are using the for loop total of 4 times here. So we don't want to write three functions here for doing this, but I can always shorten this for loop. And let's see how we can do this. So we can use macros here. So let me first run this program. Yeah. So you can the array contents. Okay, okay. Nice. Yeah. So array contains 1, 2, 3, 4, 5. Then I scaled each element by 2, so it becomes 2, 4, 6, 8, 10. Then added 2 to each, so it becomes 4, 8, 10, 12. 4, 6, 8, 10, 12, right? So now I will eliminate the need of calling using this for loop every time, right? For writing for I equals to 0, I is less than 5, I plus plus. So what I can do, I can use an array, right? Macro. So how to declare macros? I can use this define construct, right? And then I am using the name of macro as f, and the input will be n. And you have to replace this with for int I equals to 0, I is less than n, comma I plus plus, right? And then wherever you are finding this statement for int I equals to 1, 0, I less than n, you can simply call f of 5 here, and it will replace it with this, right? Whenever you are using for loop, you can simply write f of 5 here. Right, everyone? So you can always do this. And now, yeah, you can see the output, everyone. Can you see this? We were able to do the same thing using macros. So the array contents are 1, 2, 3, 4, 5. The array with elements scaled by 2 is 2, 4, 6, 8, 10. The array with elements added by 2 is 4, 6, 8, 10, 12, right? The program is correct. And let's see what we did. We removed all the for loops with f of 5, right? So instead of writing this for I equals to 0, I is less than an I plus plus, what I did, I declared an array that takes f whose name is f and the input is n, and it what it replaced with. So the program, what the compiler does, it searches for f of n everywhere, right? So f of 5, then this and this f of 5 is replaced with this line for int I equals to 0, I is less than an I plus plus, right? So instead of writing for loop again and again, you can simply write 4 characters, right? F and pass the value 5 to it. That's it. Anyone do you have any doubt? This was a really good usage of macros. This is how you can use macros for your programs. This will help you to shorten multiple program segments that are called again and again. Anyone do you have any doubts? Great. So this was all about macros. So let's move back to our program. Okay. So macros are done. So I'm going to solve a problem on the next thing I want to cover is operator precedence. I hope you remember the rules. So I'm going to solve this. So do you remember how we used to solve these operator precedence problems? One way is just write the C program and you will see the output. But let's say in the exam, it asks you to solve this and tell you and write the answer of what will the output of this statement expression. Int result equals to 5 plus 6 minus 2 double ampersand 1 double or 0, right? So how to solve this? We will be using operator precedence. So let me copy the operator precedence table here. The precedence. So first, what you need to do, you need to extract the operators, right? Extract the operators. The operators are equals to, then plus. So I'm not using comma because comma is also an operator. Minus, then double ampersand and double or, right? Then let me write them in the order of precedence table. What is the order? Higher to lower, right? So let's see which has the highest precedence. So equals to plus minus double ampersand double or, right? Plus minus has the most. Then plus comma minus plus and minus. Then the next one is mm, right, mm, plus minus and then double ampersand, right? Then double ampersand, then double or, and then assignment. So double ampersand is basically and operator, double or this is double bars or operator, and last we have this equals to operator, right? So you all know what these operators do. And then there is one ambiguity here, which operator to resolve first. You use the associativity, right? And for plus minus addition subtraction, the associativity is left to right. So you use associativity, and that gives you first you plus and then you do minus, left to right. So whatever comes into the expression first will be evaluated first, and then the next one. This is the associativity left to right. Let me write this. This is basically left to right, right? So let's start by solving the problem now. So the expression we got was result equals to 5 plus 6 minus 2 double ampersand 1 or 0, right? So the first operator precedence goes to plus because it is left and it has the highest precedence. So let's resolve this. 5 plus 6 is, so let me do this. It is 5 plus 6 double equals to 5 plus 6 minus 2 double ampersand 1 or 0, right? The operator precedence says we have to resolve 5 plus 6 first, right? What is this value? 11 here. So let's put 11 here. And then you copy the exact expression again, minus 2 double ampersand, right? 1, this is 1 here, right? This is or, and then this is 0. Then again, the next operator precedence, highest operator is minus here. So you resolve this block, 11 minus 2, which becomes 9 here, right? Then you have equals to 9, then double ampersand, then 1 or 0. Again, what is the operator precedence table says here? You have to resolve double ampersand first, right? So double ampersand. So what it says, A and B. And we all know integer values. So whenever you are applying Boolean operators in this onto integers, the all non-zero integers will be treated as ones, treated as true, and all zero will be treated as false. So 9 double ampersand 1 will return 1 here, right, everyone? I hope you remember this when you apply booleans. So all integer values which are non-zero correspond to boolean true, and which are zero corresponds to boolean false. So this equals to 1 or 0. So this means 1, so true or false. So and you already know the output of true or false is 1, right? It will return true. So now finally you will resolve this equal to operator, and this will say result equals to 1. Fine. So the variable result will store the value 1. So this is the final answer. Yeah. So result is equals to 1. This is the final answer. Anyone, do you have any doubts in this? This is how you solve problems on operator precedence. If you have any queries, please type in the chat box. Anyone? Great. So let's move on to the next problem. So you all remember this comma operator, right? So I have not covered the most popular operators ones because every one of you, all of you have done lots of problems on them. You should be able to solve them. I'm covering those operators that you might miss, right? So one of them is the comma operator, right? So let's say we have this, let's say. So let's say we have this expression. How to resolve this, everyone? Let's go ahead and collect our operators. One, then uh, this is post plus plus, post fix basically, then plus equals to, then multiply, and then finally comma. These are the operators. So what we do, we define the associative, operator precedence, right? So let's write the operator precedence. Precedence high to low. The higher one we evaluated first. So as of the first thing that will be evaluated is post plus plus, right? Then you have mm, okay, right. Then you have multiplication. So multiplication will be evaluated first, right? Then you have mm, plus equals to. So now you have three operators equal to, and two operators equals to and plus equals to. So this is ambiguity to, you will check associativity, right? Associativity says right to left, right to left, right? Then the next operator you observe is the comma, the having the least precedence among these, right? So let's go ahead and solve this problem. Yeah, it's really be easy. So we have equals to, let's assume result is on the left hand side always, right? Let's call it res, and we have res equals to a plus plus comma b plus equals to 5 comma c multiplied by 2, right everyone? Let's say we give some initial values to a, b, and c. So a has the values 2, right? Has the value 0, and C has the value 1, right? So let's go ahead and solve this. So let's see. Operator precedence table says postfix plus plus has to be evaluated first. So you will evaluate first. Then you will see, so you know, postfix says use the value and change in the next line, right, everyone? Which where is equals to plus equals to? There is no plus equals to equals to plus equals to in this, right? Yeah. So a postfix says the value of a will become 3, but from the next line. So in this expression, the value of a will always be 2. It won't be 3. So it's 2 here, and then let's copy the uh, previous expression again. 5c multiplied by 2, right? Now the next operator precedence belongs to multiplication. So so you evaluate this part, you will get c equals to 1. 1 into 2 is 2 basically here, right? And then 2 was here, and then you copy the entire expression again. So it says b plus equals to 5, right? So what is the next operator that we want to resolve? The next one is equals to and plus equals to. Associative is right to left, right? So right to left. So this means the operator that comes into right will be evaluated first, and the right one is b plus equals to 5 here. So you evaluate it first. This says the value of b equals to b plus 5, right? So b was initially 0, so the value becomes 5 here, right? And you get 2, 2. And you know that equals to operator plus equals to operator returns the value, just like the equals to operator, right? So you get the value 5 here. And finally, you evaluate the next operator is uh, eq- uh, the next operator you observe is comma. Okay, okay, right. So this will give an error, right? This will give an error because if you evaluate this equals to here, let me see. Okay. Yes. This won't give an error, but yeah, you have to evaluate this equals to operator first, right? So you have to, so let's get result here, and you need to evaluate this first, right? So this means this says the value of result is now 2, and then you get the value 2, and further evaluation is not useful because this comma operator has the least precedence, and it says basically evaluate something a thing on the left, then discard it, then evaluate the thing on the right, then discard it, and then evaluate the thing on the last part, and then return it to the left hand side. But on LHS you don't have anything, so the value of result becomes 2 in this, and this is the final expression. So this is how this problem is solved, right? Everyone, do you have any doubts? Anyone? Great. So let's move on to the next question. So you all know this one basic thing with the assignment operator. The assignment operator returns the value, right? You all know this. So yeah. So what this statement means? This means x as the value 2 because equals to operator returns the value, right? Is this clear, everyone? Do you have any doubts in this? Great. Then I have already covered functions here, so I don't think we need this. So one thing that I think we missed is two-dimensional arrays that I want to cover up here, and then our session will be almost over, right? Because other things have already been covered in previous sessions. So in C, you can create multi-dimensional arrays, right? So earlier we saw we were able to create arrays containing sequence of values. So int arr 5 containing 5 elements, right? Now what if, let's say now we want to do maths, some linear algebra on using C programming language, right? So we want to store vectors. So this is a way to store vectors, right? You know what are vectors? So vectors are values, sequence of values having directions, right? So it is one, two. So for example, I use a simple example to explain you what are vectors. So let's say in the Cartesian plane, you want to store the vector 1 comma 1, right? So this is x and this is y, 1, 1. Hmm. So what does how so you can always draw this vector, right, from the origin to the point 1 comma 1, and this is your vector, right, everyone? You remember this? So in your physics class, basic class 12th physics, 11th physics class, you have already seen vectors. So the question is how to store these vectors in C. So like for example, we can store strings, characters, we can store numbers in the C programming language. But let's say we want to do some vector algebra. How to do this? How to store these vectors, right? So the all those the integer values were scalars. Now you want to store vectors. So for vector, you need at least two elements to define a two-dimensional vector. For example, vector 1 comma 1. So you do this using arrays. For example, like this int arr array containing two values equals to 1 comma 1. This means we are storing a vector 1 comma 1 using integer array, right? Now, similarly, you all are familiar with the concept of matrices, right? You all know what are matrices, right? So a matrix that looks something like this. Let's say 1, 2. So let's say we want to store this identity matrix. You all are familiar with the concept of identity matrix, right? So this is an identity matrix. So how to store this matrix in the C programming language and then do operations over it. So right now I we have already seen how to do operations on arrays, right? So we can store similarly we can do operations or vectors by storing them as arrays and doing the various operations. For example, vector dot product, vector cost product, vector addition. Thus you can see by accessing the elements of this array. But now I want to do this with matrices. I want to define matrices and do matrix addition or matrix vector product, something like that. How to do this? We can always use two-dimensional arrays, right? And how to declare two-dimensional arrays in C? You can declare so let me get this to the next page, right? Yeah. Mhm. Huh. So now we will be using two-dimensional matrices to store two-dimensional arrays to store matrices. The syntax goes like six. Let's say I want to create an integer array. integer matrix containing integer elements. So I can use this syntax int matrix, right? And then two square brackets. Two square brackets means you are going to create two-dimensional array, right? The one thing to note here is, like arrays, you cannot so the second so in the second square block, you have to define the size of each dimension in the two-dimensional matrix, right? So in two-dimensional arrays, you create m cross n array with, let's say, m rows and n columns. This means each row contain n values and there are n rows, right? So int row, int matrix, and then number of rows in the first square bracket and number of columns in the second square bracket, and this is necessary. So uh, we can omit the number of rows, but number of columns is necessary during the declaration during declaration of a 2D array, right? Two-dimensional array. And most importantly, for any n-dimensional arrays, you have to define all the size of all the dimension except for the last dimension. The last dimension can be left, and that can be changed. That can be a variable, right? Why this is the case, why number of columns is important? This is related to how C stores multidimensional arrays. So basically, it needs to know how much each block of the row will be storing, how much storage will each row require, so that it can divide the rows, store the rows into the main memory, right? So this is about two-dimensional arrays, right? For example, I want to create this identity matrix, so I can call the integer, and I call the name as I because I denotes the identity matrix. It contains two rows and two columns, and I can store in the values like this. So first row followed by the second, right, everyone? So you have first curly bracket that encapsulates each row, and then this is the first row and this is the second row, right? In the inside brackets, how to access the element? As accessing the elements, you can say I at 0 0. This is how, in general, you can use I at I comma j, right? This is how you access the matrix entries of a two-dimensional matrix, two-dimensional array in C. Right, everyone? Is this clear? Do you have any doubts for these? Anyone, do you have any doubts for the arrays, two-dimensional arrays? Great. So this was all. Other than that, here are a few other major topics that were covered. If you want me to, then I can explain these. Otherwise, yeah, feel free to ask any questions related to all the topics that have been covered throughout the semester, right? So now it's a Q&A time. So you can ask me questions. I'll be answering your questions. This is a matrix. This is a vector. Anyone, do you have any doubts? You want me to cover any more topics? Okay, call by reference. Okay, so let's see how it works. So is it fine if I just show how it works instead of writing a program? Right. So call by reference. So whenever you way of passing parameters to functions, right, everyone? So what is call by reference? It's a way of passing parameter to functions. So let's first see how to do this, how to use this, and then I will explain what is going on. So let's say I have a function void, and I call it a void increment, and I take in variable x, and inside the function, what doing, simply writing x plus plus, right? And then there is my main function, and declaring a variable a containing value 10, and then I call the increment function over this. Then I say I print the value before function call, right? A, and then I print after function call, right? Percentage d, A. Right. So everyone, anyone, can you tell me what will happen? What will this line print here? Anyone? What is the output of this line? So yeah, you had doubt, Prajwal. Can you tell me? Okay, okay. So let me put a line change here also. So I'm changing the line after I'm printing the values. Yeah. Now, Prajwal, yeah, Light, your answer is correct. Prajwal, do you get this? What is happening here? This will print 10 onto the terminal, and this will also print 10 onto the terminal, right? So what happened is, this is what you do when you are doing call by value. So call by value, what it says, the value stored in this parameter a has been copied to the value x here, and some operation is done here, and that's it, right? Now this is called by value. So whatever changes have been made to this object x here, that those changes are not visible in the variable a, because you are simply copying the value of a and storing into the variable x. Now after the function exits, the value of variable x will be deleted, right? So I can also write here, right? I can also write a printf statement. The value of variable x percentage d backslash n, right? And I can also print the value here, and you will see this line will print 11, right? So you can see the variable x has been changed inside the function, but no changes has been done to the variable a here. So this way of passing parameters to function is known as call by value. Then there is another way to do this, is call by reference, in which you want the changes to be reflected in the variable a itself here, right? So for that you have to modify your function. So how it is done, you pass the address of this variable a to the function. Instead of passing the value, you pass the address of the variable a, right? So you can use this ampersand operator here. So inside the increment function, I am passing the address. And then on the receiver side, you have to receive a pointer. Why? Because whenever you are receiving an address, all the addresses belong to the data type of pointer. So you are writing int star x. So this means an integer pointer has been stored in the variable x. Now you can do the operation on this, dereference the point value stored at that location, and do the operation, and then print the value by using the dereference operator. And in this case, Prajwal, can you tell me what will be the outputs here? What you will see here? This was 10 here. Now, again, you are receiving a pointer, dereferencing and incrementing it by 1, and then dereferencing and printing the value. So you will get 11 here. So what will the output here? Prajwal, can you tell me? So I'm not getting any answer. So yeah, let me just tell. It will be 11 here. Why 11 here? because now you are passing the address to the variable a. Let's look at the main memory, what is happening, and then we can see what happened actually in the second case, right? So let's say a was stored here, the variable a was stored in this memory location, right? A was stored here. So Prajwal, is this clear? So I'm just drawing the main memory layout. So let's say this memory location is 1000, memory address 1000, and a was stored here. And initially the value of a was 10, right? Then you made a function call, and in that function you are using a variable x, right? And so in the function call, you are passing the address of the variable a here, right? And you are receiving that into the pointer variable x here. So this is a pointer variable x. So let's say the pointer variable x is created here. So this is the pointer variable, right? So this is a pointer variable x that contains the value 1000 here. But why? Because I'm passing the address of variable a to the function variable x here, right? Now, whenever I calls asterisk x, this means the value stored at this memory location, right? So when you are in the function, you call asterisk x. So now what you are saying, go to the memory location 1000 that has been stored for this pointer variable. So this is memory location 1000. And in that memory location, what you have to do, you have to do the operation. So what you have to do, you have to do 10 plus 1, then becomes 11, right? Now again, what is the value stored at that memory location? The value stored is 11, so you print 11 here, right? Now when the function exits, you come back to the main function, and then you print the value stored at the memory value a. So this means, what is the value stored at the memory location of variable a? The value stored at the memory location of variable a was 11 here. It has been modified by the function. So this is how you use call by reference to make changes to variables in the main function itself without copying values here and there. Right? Is this clear, Prajwal? So instead of just passing the value of the variable, you pass the memory location at which it is stored. And then you can use the reference operator to make the changes. Great. Whereas in call by this was call by reference, right? Any other doubts, please type in the chat box. Otherwise, if the session is over, right? If you have any other doubts, just type in the chat box. Otherwise, please, we can leave the session. And for reference, I'm just giving you what was happening in call by value. So in call by value, what was happening? So this is the main function, right? Main memory. This is the main memory. Main memory. So this was variable a stored here, right? At the memory location 1000, the value was 10 here, right? As soon as the function call begins and the value of a is passed to the variable x, so what happens? New variable x is created at some other memory location, let's say 2000, and the value stored in the memory location of a is copied to this memory location. So 10 is copied here. Then when the increment happens, the value becomes 10 plus 1 equals to 11 in this memory location itself. In the memory location 2000 only, nothing is changed here, 1000, right? So it prints 11 here, and then when you access the value stored at memory location of the variable a, you still get the value 10 here, right? So this was happening in the call by value call. Anyone, do you have any doubts? The session is officially over, so thank you all. So if you have any doubts in this program, you can ask me, otherwise we can end the session, right, everyone? Anyone, do you have any doubts? I guess Light is typing something. Please type it. Otherwise, you can leave the session, right? We are done with this. So some of you guys are still typing. I'm not sure what you are typing. So let me stop the recording here. Other sorting algorithms. I don't think bubble sort and selection sorts were taught. You can look into the video lectures. I'm not sure about that. So regarding the syllabus, you can look at the NPTEL lectures, right? So I'm not sure about the questions that would will be asked in the session in the test because those are managed by the NPTEL team. So I'm not the right person to ask those questions. Yeah, thank you all.